Good morning, everyone. We'll get going here. So welcome to the first Oil and Gas Commission webinar. Today's presentation will be on water use in the oil and gas sector, and it's primarily focused in Northeast BC. And the presentation is done by the hydrologist at the Oil and Gas Commission. So I'm Susan Lapp, and we will begin. So just a few housekeeping things at the start here. So if you have any questions or comments, please type them into the comments box. You should see that on your GoToMeeting header. All questions that we have we'll address at the end of the presentation, so please just keep your phone on mute, and that way the presentation can just flow smoothly and we will answer them at the end. Any questions that we do not address, we will follow up directly with you. And if you have any follow-up questions, you can send them to the email address that's written on the screen there. So stakeholder@bcogc.ca. And a link to this presentation will be emailed to all registrants, and we will also post it to the OGC website at an upcoming date. And just a reminder, can everyone please mute their phones? So who am I? I get asked this question many times. I'm new to the Peace River region area. I joined the commission back in November 2017, and I moved to Fort St. John April 2018. So I am coming up on a little, just shy of a year being here. So almost one full hydrologic season, we may say, in the water world. Who am I? I'm a hydrologist, and there's the scientific definition of who I am. Basically, I'm interested in surface water. So there is a difference between a hydrologist and a hydrogeologist. Hydrologist is surface water, so everything you see flowing on the surface, versus a hydrogeologist, which is everything when it comes to water below the ground. And today's presentation is focused only on surface water. My role here at the Commission is to provide technical support for all water management decisions, again, associated only with surface water. So a little bit of an overview from the OGC's perspective. So we do regulate water. We are mandated under the Water Sustainability Act, and we regulate water only for oil and gas purposes. So if you're a farmer and you're interested in an irrigation license, you will go down to the Ministry of Forest Lands and Natural Resource Operations and you will apply there for a water license. If you are company X, Y, and J and your primary income is oil and gas, then you will come to us if you're interested in a water license or any associated water use. We'll talk a little bit about how we issue water licenses and what are called short-term use approvals, and I'll discuss the differences between them and how they're used in the context of oil and gas. And the whole intent of this presentation is to talk about how we manage water for all needs. So it's really a balancing act. And then how do we take the data that we have and how do we transform that into decisions? So how do we actually come to a decision? If you come to us for a water license or a use approval, how do we take the information that we have and how do we then know how much water we can give you and ensure that we're protecting the needs for all? So we're going to take a step back, though. I find it useful to always think about water in the broad scale. Water is very complex if you've ever worked with it, and if you haven't worked with it, I'm sure you've been touched with it, as in the flood of 2016 for those of you around the Dawson Creek area or in that region, or last spring, for example, when we had that big snowpack and we had that really rapid melt. So at some point, water has likely touched your life. But one of the things that we need to denote and differentiate is the difference between weather and climate, because we always hear the word climate change, and then we hear on the Weather Network the word weather, and they are very different definitions. And as a hydrologist, I'm interested in both of them. So climate is what we expect, and the weather is what we get. So here's a chart showing the average temperature and precipitation for Fort St. John. So this would be your climate, or what we would expect. So those green bars are the monthly average precipitation. The red lines are your daily maximum temperature, so what the typical daily high is. The black line is what your average daily temperature is, and the blue line is your daily minimum temperature, so typically your overnight lows. So if we look at the image below, that would be your weather forecast. Now this is a couple days old only because I enjoyed the contrast of this weather forecast. So we started last Tuesday with a high, which would be your daily high of -7, and we ranged down to a low of -27, and I think some of you probably experienced -35 last weekend, all the way up to daytime highs of -12. So this is how we compare climate to weather. Actually, let's just take one step back. Today is March 5th, so if we think about what the average daily temperature should be today, if I take that black line and I scroll my eyes over to the left, the average, actually let's take the red line, the average daily high should be about -3. And if I recall correctly from the weather forecast today, I think we're supposed to get to a high of -12, so we are below average today for temperature, which we all know because February was the 4th coldest month on record according to Environment Canada. Something interesting to note about why we're interested in climate versus weather is understanding the variability, and last year is a great year to look at. So let's just look at the month of May. Let's look at that green bar in May. And if you take your top of the green bar and you scroll your eyes over to the right, you'll note that the average May precipitation, so this is the amount of rain and or snow, and in May we hope for mainly rain, but the average precipitation is about 40 millimeters, give or take a little bit. Last year in May, down on the bottom, you'll see it says we received about 6 millimeters. And if you remember, we had forest fires popping up in May. So we went from where we would say we would expect to receive about 40 mils to where we actually received about 6. So if you think about the context of water management, this becomes a real challenge because we expect a lot of water, but what we actually received was significantly less. Let's look at May again, and let's look at the average temperature. So if you go to the black line in May, and you scroll your eyes over to the left, you'll see that the average daily temperature in May should be about 10 degrees Celsius. However, in May, the average daily temperature was about 14 degrees Celsius, so we were significantly drier and significantly warmer, which meant, if you were here, we had a really rapid melt and things dried out really quickly. So last year, we rarely ever met average conditions. And this is important to note because in the world of water, we're always dealing with floods and we're always dealing with drought. And so we always take this into account when we're managing water or we're making water management decisions. So although we wish things worked according to the climate and we could be guaranteed we'd always receive a certain amount of rain or we'd always have a certain temperature, unfortunately, that's just not how the world works. So let's put us into where we are here in the world. And this is important to think about. So here in Northeast BC, we are in what's called the Mackenzie River watershed. If you live around the Fort St. John region, you know the Peace River collects water, sends it to the east up through Alberta and then north. If you are north of the Sickiny-ish, everything flows north and into the Liard and then into the Mackenzie River. So we are in two primary larger watersheds that combine into one large watershed, and everything heads north into the Arctic Ocean. So this is the large watershed that we talk about. I often get asked, what kind of information do we use when it comes to making water management decisions? And because it's March 5th right now, we're starting to watch the state of snow. And if you're a farmer, you know that the amount of snow that you have on the field right now is setting you up for the type of crop you potentially can have this year. Or if you're looking at filling your dugout or reservoir, you're looking to ensure that, do we have enough snow, or am I going to have to look for a supplemental supply of water potentially? So knowing how much water is out there in snow is key right now when it comes to setting us up for the entire year around water. So one of the things the province has set up around the province are what's called snow pillows. And they collect snow data and post it to a website that's publicly available. And we use this information regularly, particularly at this time of year. So those snowflakes right there identify locations where the province collects snow pillow information or snow depth information, or what's called snow water equivalent. So you'll note there that I highlighted one snow pillow station, which is called Crying Girl. And the chart that just popped up shows to you historically what the snowpack accumulation has been like over the last number of years. So the blue line there shows what the snowpack was last year. So, sorry, that's this year. So the green line shows you what the snowpack was last year. So 2017, 2018, and it is fairly high. So last year was a high snow year. This year, we're 2018, 2019, which is that blue bar, and you'll note we're kind of set on right on par right now. So we're on average conditions, or maybe just a little bit above average, depending on where you are in the province. So things right now from a water standpoint are fairly good. And of course, this feeds into fire, and this feeds into floods, and this feeds into droughts. So we're monitoring the snow pillow information on a fairly regular basis to see where we're at. So come again in April, we'll monitor this information again, and we'll have a good sense where we are headed into the future. Stream flow information is also key. So how much water do we currently have coming down our rivers or our streams? We monitor this through Water Survey of Canada. Water Survey of Canada has a number of stations set up across the province and the country, and we monitor these regularly. The map that you're looking at right now is from what's called the Water Portal, and this is managed by the OGC, and it's a free data sharing platform where users can go and identify where Water Survey of Canada stations are and then determine what the actual flows are. So in this case, we're going to look at Murray River. This is just south of Tumbler Ridge. And this is what a Water Survey of Canada station gauge looks like. So if you've happened to have been on a riverboat and you've driven by this location, that apparatus right there is monitoring the stream flow within Murray River. What that translates into is something that looks like this, which is called a hydrograph. So this gives us a sense about how much water is actually available in the Murray River right now. So that chart right there shows you on the left-hand side cubic meters per second, so how much water is flowing down the river. The bottom of the chart shows you each month. So it starts in last March, and it shows, if you follow the orange line, that shows you average conditions. The blue line is flow from last year. So last year we had a really early freshet. We had lots of water coming down, and you can see that identified by that blue line. And then things dried out really quickly in May, and you see that blue line really drop off. And then again in June we had a lot of rain. Early July we had a lot of rain, and you see a spike again in that blue line. And if you look today, and I grabbed this yesterday, which was March 4th, we have above average stream flow in Murray River. So we use this information on a regular ongoing basis as well to get a sense about how much water there is across the province. So as we're talking about weather, it's important to think about how have things changed and what is the relationship between the weather, that being the precipitation and the temperature, and how does that impact stream flow? So how have things really changed? So I'm going to show you a few different charts here. And because I'm a bit of a nerd and scientist, I enjoy looking at data, and that's primarily what I do every day. But this really falls into how we manage water. So these four charts show you precipitation in Fort St. John. So again, precipitation is a combination of either rainfall or snowfall. So winter, spring, summer, and fall. These combine 3 months. Winter is considered December, January, February. Spring is considered March, April, May. Summer, June, July, August. And fall, September, October, November. And I've highlighted or circled 5 years there, 2008 to 2013 in each 4 of those seasons. The orange line identifies what the average conditions will be. And rarely, you'll notice across each one of those 4 charts, does precipitation during any season actually reach or align with that average condition. But what you notice between 2008 and 2013 is that some years we have really wet years and some years we have really dry years. Particularly during the winter, you'll notice that 2009, 2008, 2009, 2012, and 2013 were dry. Spring, we have more average conditions. Summer and fall, we're starting to see a lot of years that are below that orange line. And this is important when we look at, or if you just think back into your memory, how have things been changing? So this is the Moberly River. I've tried to show examples across the province or across Northeast BC. How have flows then changed across the different seasons within the Moberly River? So again, we have summer, winter, fall, and spring. And I've again circled the same years that corresponded to the seasonal precipitation, so 2008 to 2013. And what we see there in the top left chart are the summer flows, and they're not too bad. On some years we have dry years, so 2010 was a relatively dry year, but all in all, not too bad. Winter flows, they're below average, but not terribly below average. But where you really start to see things kick in are in those fall flows, where in the last number of years, particularly 2008, 2013, and unfortunately the data for 2014 to 2017 isn't available yet, but there isn't one year where we actually saw flows reach what we would consider to be average conditions. So for those of you out there saying, man, things sure seem to have gotten dry lately, or I've really noticed that those summer flows are a lot lower than they used to be, or fall flows, you're right, that's exactly what we're seeing out there. So how and why is that? Well, it's important to understand the relationship between precipitation and flows. So here what we see is summer precipitation and fall precipitation on top, and how that relates to fall flows. So 2008 to 2013 for the summer and fall, we saw pretty much always, except 1 or 2 years, below average precipitation, which when you translate that into the volume of water that flows down a river, we're seeing less than average. So what you're seeing is correct. So low precipitation is equal to low flows. So in the context of water, we're always watching how much snow do we have, how much rain do we have, and how does that then translate into how much water is available in a system. Oh, can we just have someone mute their phone again, please? And in case you haven't noticed, I quite like the weather and I continually watch it. And so from the context of where we're sitting right now, I like to see what's coming up in the future, particularly after we just had the wonderfully cold month of February that we had, to see what do the next few months look like up here in Northeast BC. So this is done by Environment Canada. This is conducted by some of the modeling experts that they have, but it shows their forecasts for temperature on the left and precipitation on the right as to what they project will be the future 3 months. So on the left, if you can kind of squint your eyes, Fort St. John is Northeast BC. We're probably right on the edge of that blue line, which means that we are either going to be maybe on average for March, April, May, or likely slightly below the temperature for March, April, May. So things, according to Environment Canada, are going to continue on this cooler than average trend. Now on the right-hand side, when you look at the precipitation, we're in that brown bubble, and that brown bubble corresponds to us being drier than average. So according to Environment Canada, the next couple of months look like we're going to be on average to below average temperature, and likely below average precipitation, so drier than average. So of course we're watching this when it comes to water. How fast will snow melt? How much more snow may we get? And what potentially could be the forest fire season this summer? So water units. This is a question I often get asked. In the water world, we talk about water in cubic meters per second. And I don't know how many people have gone out there and actually taken a meter stick and gone, here's how big a cubic meter is, but I typically don't do that in my spare time. But if you want to know how much a cubic meter is, it's about that big right there. So it's about a meter by a meter by a meter. If you can pretend you're that man standing there, it comes to about your waist. And if you were to reach out by your arms, about that big by about that big again. So that's 1 meter. 1 cubic meter is in relation to or equals 1,000 liters. So if you think about your 1 liter milk carton, 1,000 of those equals 1 cubic meter. So when we measure water by how fast it flows and the volume of water flowing. So when I talk about the Moberly River and it being 10 cubic meters per second, I'm talking about 10 of those cubes flowing per second. And you can relate that to how fast you drive your car. But it gives you a sense about how much water is coming down a system. A water truck, I'm sure many of you guys have seen one of these things before. They're on average about 15 cubic meters. 10 to 12 or 10 to 15 on average, about 15, just to give you a sense about how big they are. So when it comes to authorizing water, we issue 2 different uses. One is called the Section 10, according to the Water Sustainability Act, and that's a short-term use approval. So these are for up to 24 months, so they're typically a shorter time period. Typically, they're for a smaller volume of water. Generally, these are from dugouts or they're used to build ice roads. Some companies will submit a use approval when they're interested in exploring, is there enough water that we can do a hydraulic fracturing exploration, or is there enough for fracking, prior to submitting a water license. So they want to get a sense as, is there enough water before we go to all this effort to build out our development and then apply for a water license. One of the values that we have when it comes to use approvals is we can restrict use approvals, or we can basically suspend short-term use approvals during periods of drought. So I'll talk about that in a little bit. And to date, we have about 250 active short-term use approvals across Northeast BC. So the example on the left just shows you what one would look like. Here's the number of it, the period that it's active from, so June 5th, 2017 to June 4th, 2019, so it's just shy of 2 years, so 24 months. This comes from a stream or river. It's for oil and gas purposes. It shows you the location. It's from the Beaten River. Talks about how much water they can withdraw. So in this case, it's 69 liters per second, or it's 0.096 cubic meters per second if you want to get technical. It talks about how much water they can withdraw per day, which is 6,000 cubic meters per day. And the total withdrawal volume is 300,000 cubic meters. A Section 9 under the Water Sustainability Act is a water license. And if you're a farmer or a rancher out there, you may have a water license associated with stock watering or irrigation or domestic use. And those have an unlimited date. In other words, they never terminate at this current time. Within the oil and gas sector, we issue water licenses from anywhere from 2 to 20 years. On average, our water licenses are 5 to 10 years. This ensures long-term development plans and guarantees a source of water. So if you're a company and you're going to do a build out, you want to ensure that you have a guaranteed source of water, and a water license allows a company to have that guaranteed insurance. When we issue water licenses, they go through a high level of scrutiny and a lot of detail is required. And I'll walk through what's required in a water license. Within a water license, we protect the environment through a number of drought conditions. So we put in what are called environmental flow needs thresholds. In other words, if flows in a river get below a certain discharge or a certain volume of water that's flowing down a river, no withdrawals will be allowed from a river. So for example, last year we had really low flows, and we'll go through, and depending on what that threshold is, you will be then cut off from pumping. And we'll also put in pump rates, so you can only withdraw water at a certain rate. To date, we have about 50 water licenses that we've issued through the Oil and Gas Commission. Water sources used for the oil and gas companies. Water is accessed from deep saline groundwater, flowback water and produced water, so they recycle and reuse water up to about 40%. The City of Dawson Creek reclaimed water, and of course freshwater sources include streams, rivers, dugouts, lakes, and reservoirs. So when it comes to decision making, there are two questions that I ask and we ask. Is there any water available? Is there any water available for allocation? And how much water is required for the environment and other users? So when I talk about allocation, allocation is in the context of a Section 10, which is a short-term use approval, or a Section 9, which is a water license. So that's water that's being allocated for use. And the answer is, well, it really depends. Depends on natural variability. And I showed you earlier about how much the climate and the weather have been changing over the past number of years. The location of where the water is wanting to be withdrawn. Is it in the mountains, is it in the foothills, or is it the plain? Because they're all very different hydrologic regimes. What are the environmental or the aquatic needs? Who are the other users on the system? So do we have any agriculture, irrigation users? Do we have water providers such as the City of Dawson Creek? And are there any other recreational users? And those are just an example of other users, and there's many other examples of users. And then, of course, it comes down to the type of data and information available. How much is available? When it comes to how much water is available, there are two different, within the Water Sustainability Act, we follow what's called Section 15, which refers to environmental flow needs. And this ensures that there is enough water left in the system for the needs of the aquatic ecosystem. So Section 15 ensures that we always allow enough water to be left in the system. And to do that, we follow what's called the Provincial Environmental Flow Needs Policy. And this allows us to allocate up to 5 to 15% of the water that's available within a system. And I'm not going to get into the details of that, but if you're interested, you could do a quick Google search and you can find that EFN policy. And it walks you through a little flow chart that says, can we allocate 0% or 5% or 10% or 15% or potentially 20%. If you're really interested in more details, we have two manuals available online, and I'll show you where that website is in a few minutes. But we have a water license application manual, and we also have a short-term use manual. So let's walk through a quick example. I find it easier to just pretend that I'm a company and I'm going to ask for a water license. And so, Sue Lapp Inc. water license application. What kind of information do I need if I'm an oil and gas company? Do I need to submit to the Oil and Gas Commission? And then how do we go about making a decision as to whether or not there is enough water available and what that water license would look like? So within my water license application, I'm required to supply the point of diversion. So where am I going to be taking water from? What is the stream name? So is it along the Kaskatna, or is it along the Moberly, or is it along Creek X, Y, and Z in somebody's backyard? The volume of water that's being applied for, so how many cubic meters, and how fast am I going to be pumping the water at? Who are the other major users on the system, both upstream and downstream? I expect a detailed hydrologic analysis, so how much water is available on either a weekly basis or a monthly basis, and how much water is required for there to be left for the needs of the environment or the aquatic system. So there should also be an environmental flow needs assessment. So here's an example. Let's assume this is our stream, and I didn't actually give our stream a name, but if it's in my backyard, I'll call it Sue Lapp Stream. The place that I'm interested in taking water from is that purplish red color X that's partway down. Upstream, there are a number of use approvals. So use approvals are denoted by that yellow triangle. There's also a water license upstream that's denoted by the red triangle. And there's a water license application just upstream of that point of diversion that I'm interested in taking water from. So in my application, as you'll notice in the bottom left-hand where the text box is, I would like to withdraw 450,000 cubic meters of water per year. And I'm going to store that water in some sort of a reservoir or dugout. I'm interested in taking water from April 1 to July 1. I want to take it at a pumping rate of 0.1 cubic meters per second, or that's 100 liters per second. Currently within that system, there's already 0.1 cubic meters per second or 100 liters per second being taken during that period. And so the total diversions, if my license were to go forward, would be 0.2 cubic meters per second or 200 liters per second. So this is the kind of information we would expect to see. And of course, there'd be a lot of math and stats and numbers that would go into an application. And primarily what we're looking for is what are the average monthly flows? So kind of like climate, what would we expect to see? And then what historically have we seen for low flow conditions? Because we're always worried about how much water is available during those low flow years, because we always want to ensure that there's enough water left for other users and the environment during those low flow years. So all of our analysis is done on low flow years. So here I see minimum flows and what's called a 1 in 10 year flow event, or there's a 10% likelihood that we will see flows reach that blue line. So you don't need to know the details of this chart. All you need to understand is that there's a lot of analysis that goes into understanding low flows. So we go through a whole lot of math, and this table gets quite complicated. But let's assume that, maybe rather than saying we wanted this water license from April to July, maybe it started off we actually wanted it from April to August. So there's my 5 months on the left-hand side of that chart. The average flow is the second column there. The average flow of April is 15, 20 in May, all the way down to 5 in August, so that's cubic meters per second. The total diversions within that channel are 0.1 cubic meters per second. I'm interested in also withdrawing 0.1 cubic meters per second. So I go through and figure out if we want to take 0.2 cubic meters per second of that average flow, how much water am I actually potentially taking? So we assume that every user on that system turns on their pump at the same time and they all start pumping water out. Even though that's typically not how it works, we always assume the worst case scenario. So for example, in April, if we assume that I turn on my pump and every other user on that system turns on their pump, and the average flow is 15 cubic meters per second, we would be taking 1.3% of the water that's available. So not a whole lot of water, and according to the BC EFN policy, we would be okay to go. We also put in licenses what are called EFN threshold conditions, meaning that when flows get below a certain discharge or stream flow, no pumping is allowed within that system. So you'll notice in April, the very last column on the right says the EFN threshold is 8 cubic meters per second. So when the flow reaches 8 cubic meters per second, Lapp would then therefore not be allowed to take water. I said earlier we were interested in low flow conditions. So yes, we look at how much water is being taken during average years, but realistically we're interested in how much water can be taken during those low flow years. And at the Commission, we work really hard to ensure that there's always water available in the environment. And so let's assume that we have an environmental flow needs condition as we have in August of 2 cubic meters per second. And let's assume that we all turn our pumps on at the same time. Technically, if we're allowed to take 0.2 cubic meters per second of that 2 cubic meters per second, you can see some fancy math there, that would be taking 10% of the water that would be at that low flow. And based on our insurance to ensure that there's always water available for the environment, we would not allow water to be taken at those conditions because we're already pushing the limit there. So typically we try to keep things below 10%, 5 to 8% on average, and that includes all users within the system. So there are a number of conditions that we put in place to ensure that there's always water available for other users and for the environment. So in this case, what we're really working with the client to do, which would be me in this case, is to withdraw water during spring when there's lots of water and to put it into storage so you can use it during periods of drought. So here's an example of a water license. This is on Bissette Creek, and this is for, if you're interested, this is an Encana water license. So Encana can take 450,000 cubic meters per year, and they can store it, and they're allowed to use it from April 1 to July 31st. And at the bottom there, you'll notice that we have a number of environmental flow needs conditions or thresholds where if flows reach below that volume, they are not able to take water. So a number of conditions get put into water licenses. So one of the tools that we use, and I've already talked about a number of tools that we use or data resources that we use to make water management decisions, is called the Northeast Water Tool, or NEWT. And you may have seen this, or you may have even used the NEWT tool. So this was developed by the Commission back in 2012. And basically it provides us average flow conditions on a monthly basis for each watershed and tells us how much water has been allocated. And it's a great tool. It's based on Water Survey of Canada information. It incorporates environmental flow needs protection, and it sums together how much water has been allocated for both short-term use approvals and water licenses for both Oil and Gas Commission and those that have been licensed through the Ministry of Forest Lands Natural Resource Operations. And it provides a really high-level overview of water availability. This tool, they figure, if this tool was not available and you as a water officer were asked to go through and do a water license, it could take you many days, I'll say many hours to many days, to go through what this tool provides you in a matter of minutes. So on the water allocation side of things, this tool has been a real lifesaver. So some of the output from NEWT, just to give you a little bit of an overview, and I don't know exactly where I grabbed this chart from, but it shows you what the month is, it shows you what the mean runoff is, so how much it is in millimeters, it shows you what the mean discharge is, so how much stream flow is actually coming down that channel. In cubic meters per second, talks about the mean runoff, it talks about the flow sensitivity, and if you're interested, you can look up the BC Environmental Flow Needs Policy, and it'll talk about that. And then it tells you, which is the green column there, how much water needs to be left in the environment to ensure the needs of the aquatic system are protected. And then it talks about, in the orange column, how much water can potentially be allocated. So based on those two columns, we always ensure there's enough water left in the environment, and it always tells us how much water potentially can be allocated. Now this just gives us a really high overview. If you were applying for a water license, how you would go about doing this and some of the information that we would use. Some of the other conditions we'll put into water licenses are monitoring. So if there isn't enough information available on a system, let's say it's a small watershed or we don't have a lot of raw data available, we'll ask a company to put in a monitoring station to gather stream flow information. And from then they will submit that along with their, they'll submit that to us, and we may or may not post it on what's called the water portal and make it public. But companies will often be required to keep track of how much water is available in a system, and then we go back and check to make sure that the water license or the use approval that we've authorized them aligns with the volume of water that they're collecting. So this is one more check that we have out there that we get companies to do to ensure that water is available. And it also is another way for us to collect information. Storage, you've likely seen a number of these structures around Northeast BC. The value of these is that a company can take water during times of high flow, so generally April, May, June, and potentially July when we have a lot of excess water, and store it, and they can use it during times of drought or low flow. And as you've noticed earlier, we're seeing a lot lower flows in those fall months. So this ensures companies that they have water available for those periods. Water use reporting. Companies are required to report to us their quarterly water use, and we publish that quarterly in a document that is available to the public on our website. How much water is used for fracturing? This is a bit of an older fact, but it hasn't changed a whole lot. So most of the water used for fracking comes from rivers, lakes, and dugouts. Some comes from groundwater. And some companies are actually reusing or recycling up to 40% of the water. So they're using a lot less surface water than they were historically. How much water is used in Northeast BC relative to how much water is available? So that large cube there, if you notice the top left-hand text says this body of water represents 120.6 billion cubic meters of water. This is the amount of water on average that flows out of Northeast BC. The cube in the bottom right-hand side says this is the amount of water that we authorize for use, and that is equal to about 0.03% of the annual runoff. Now, the actual volume of water that gets used is there on the left-hand side, and that represents about 0.004% of the volume of water that runs off. And that's for both water licenses and that's short-term use approvals. Now, this is only for oil and gas consumption. Drought. I mentioned earlier that one of the values of having a short-term use approval, or us, the Commission, authorizing short-term use approvals, is that we can put out directives to suspend water use during periods of drought, as we have done historically in the past. So since 2010, we've issued 5 directives suspending water use through short-term use approvals, including this past year. So we monitor river levels closely, and we do that through the Ministry of Forest Lands Natural Resource Operations and the River Forecast Center. There are weekly or bi-weekly meetings depending on the level of drought, and when things get to a certain threshold, we will start to implement these water suspensions. So the question I get asked is, how do we go about making water management decisions? So the first question I ask myself is there any water available for allocation within a system? And how much water is required for the environment and any other user? And the question is, it always depends. And I really like this because it aligns with my name, so how can you not? So some water allocation principles here at the Commission that we follow quite strictly. So we always want to ensure that we protect the needs of the environment, for fish, and for wildlife. We protect the present and future water needs for all users and for First Nations. We understand and manage for natural variability and for the future changes. We recognize and respond to unusual low flow conditions, for example, drought. And we try to be as transparent as we can with all of our water information and the decisions and how we make them. And really, we work hard on collaborating with others and being innovative, as you can see through the NEWT tool and future changes that we have coming up within that water tool. So if you're interested in more information, all of this is available on our OGC Water Information website, and the information or the website has provided you there. So there you'll find a link to the Northeast Water Tool, the water portal where you can access Water Survey of Canada data, any of the manuals, so whether it's the water license manual, the short-term use approval manual, or if you're interested in the water reports and how much water each company is using according to the use approval or the water license. And if you have further information or if you have further interest in groundwater, you can go as well there to do some digging and then reach out to the appropriate people for groundwater. And that ends our presentation. So, quick note, type your questions in the box if you have any, and we'll address all questions at the end. And if not, we will follow them up, and I believe we gave you an email address earlier that I can find again. So we're just going to take a quick 3-minute break. We'll go through some of your questions, and then we will come back and start addressing your questions. If you have any more questions, you're welcome to submit them, and we'll come back in another minute and we'll start answering them. All right, so we have a couple questions. I'll read out the question and then I'll answer them. So the first question is, what is the expectation on timing for a water license application from submitted application to decision? And I wish I really had an easy answer for you on this question. There are many aspects that go into a water license. Some water licenses from date of application to date of authorization can be completed within a couple months. Others may take up to a year depending on where they're located, the volume of water requested, the timing of year that they're interested in, is there a reservoir, First Nation consultation, and other users on the system, and the amount of information we have available to make that decision. So unfortunately, I can't give you a very clear answer on that. But if you're submitting a water license application on a very sensitive system, I would highly recommend you give yourself 1 year from date of application to date of acceptance. So hopefully that answers your question. Next question has to do with First Nations. And I think I'll answer this one the way it's come in. It says, is it water in relation to the reservation, or does it have to do with the traditional territory or treaty lands? And it has to do with the traditional territory. So if a water license falls within multiple traditional territories, consultation would go out to those overlapping First Nation communities. It is not restricted to the actual reserve land itself, so it has to do with traditional territory. So that should answer that question. I have one more question, which we get asked often as well. How much collaboration is there between the Oil and Gas Commission and other ministries? And we work quite closely with the ministry, both here in Fort St. John, Prince George, and Victoria, whether it's in regards to water licensing or water allocations or on the dam safety side of things. We do work really closely with the ministry and their water training. Oh, sorry. And it has to do with the Ministry of Forest Lands Natural Resource Operations in the context of water. And we are a part of the provincial drought team. And if there is any flooding, we'll get involved with that. So we work really closely with the province. Next question, does frack water return to the surface water system? The answer is no, not at this time does any frack water ever return to the natural system. I have a couple other questions, and one question is, what is the role of DFO, Department of Fisheries and Oceans? And to be quite honest, I do not work that close with DFO. We haven't had any fish issues. DFO is associated with fisheries, and I would recommend that you contact DFO if you're interested in understanding what their role is. We at this time work really close with Flynn Rowe, but not so close with DFO on Northeast BC. But if you're interested in more detail, you can send an email and we can elaborate that, or we can chat by phone. I have a question. I have one more question. How is the quantity of water for First Nations determined? I think that might require additional information to answer that question. Quantity of water for First Nations is, with any, whether it's for a city or for anyone, is dependent on what the water needs are for. And we at the Oil and Gas Commission, unless a First Nation primarily receives unless their primary income is from oil and gas, they would go to the Ministry of Forest to receive a water license or water use approval for any water allocation. So that's a fairly detailed question that I think I need more information to answer. Here's a question. Does the OGC play a role in surface water quality monitoring? At this point, the OGC doesn't do any water quality monitoring. In some locations where we have concerns about water quality, we do have companies doing water quality testing. But as a whole, the OGC itself does not do any water quality testing. We will be implementing water quantity this spring. We have funding to install a few stations around Northeast BC, so we'll be taking that on. But at this point, no water quality. We're just going to take one more second. I'm going to filter through a few more questions to see what they are, and then I'll get back to you. Okay, we have a couple more questions. First question is a land disposition required to access water? Again, this is a difficult question to answer in one or two sentences. It depends whether it's private land or if it's Crown land, and there's two different processes that we go through to answer that question. So again, is it Crown land or private land? But yes, you are required to get authorization. Next question, is the methodology you described very typical? Do you require additional modeling? Is it all dependent on the type of application? That's a very good question. So is the methodology I described very typical? It is typical, but this is a very high level simplistic example that I walked through, assuming you had a lot of information. Depending on the system where a water license or use approval is being applied for, we will require different levels whether it's modeling or data to be collected. And yeah, it is dependent on the type of application and the data that's available. So the example I walked you through is very simplistic. It gives you a high-level overview of the process that we go through, but the type of information is very much tailored to each application. So it's very much dependent. Next question has to do with NEWT. So the Northeast Water Tool. How flexible is the Northeast Water Tool's data with new data as we undergo climate change? So currently, the hydrologic model behind the NEWT tool is based off of, I believe it's 1980 to 2012 Water Survey of Canada information. So it is historic information. And right now that system is not flexible to integrate in climate change. Climate change scenarios are available at the back end of the NEWT report that you can print off. So it'll tell you what the projected precipitation is and projected temperature. But currently those changes are not dynamic within the model itself. We are looking at a 5-year plan, hopefully to update the hydrologic model that will incorporate the new information that the OGC will be collecting and additional information that companies have collected, and of course the newest information being collected by the Water Survey of Canada data. And I think this will be our last question. Just one sec, I have to just read through this one to understand. If you are now seeing new lower flows in the fall, this indicates a change in water flow availability from previous decades. This new raw data should be what's used when allocating. Absolutely, and I couldn't agree with you more. So yes, when it does come to doing water allocations, I use the NEWT tool as an example, and that provides you a high-level overview. But when it comes to allocating water, we do use the newest information available. So Water Survey of Canada does have data available up until recently, and we do acquire that, and we go through and QA/QC it, and that is the information that is used. So yes, we use historic information, and yes, we use the most current information to make those water allocation decisions. So I think that ends this webinar. If you have any further questions, you're welcome to send it to the email address, and we can send that out to you if need be, or you can contact someone at the Commission. This website will be made available, or this webinar will be made available on the Commission website. And again, we thank you for taking the time to do this, and hopefully you found this informative. Thanks. Bye.